If you are to understand chemical bonding, or if you are to understand chemistry, you need to answer the question, why do atoms bond? This is a very pertinent question. This is a very important question for every chemist or for every student of chemistry, because chemical reactions themselves are essentially the formation of new bonds and the breaking up of old bonds. And in this case, we are having atoms coming together and atoms separating. That is a chemical reaction for you. But then the question still arises. Why is it that atoms bond? Why don't they just stay as single atoms on their own? Why don't we find them as single atoms in nature? This is a very important question. The answer to that question is that atoms bond to achieve stability. Nature itself loves stability, and the atoms are just responding, they're just obeying the law of nature, where they are moving towards stability, and they do so by bonding. Now, how do they achieve this stability? How do they achieve this stability? They achieve the stability by mimicking or by copying the noble gases. Then another question will be, why the noble gases? Why are they not copying any other elements or on the periodic table? Why are these atoms, or why are all these elements on the periodic table copying or want to mimic the noble gases? The answer lies in the electronic configuration of the noble gases. The electronic configuration, so electronic configuration, or the arrangement of electrons in the noble gases. Electronic configuration of noble gases. On the periodic table, the noble gases are in group 8. So let us write here group 8. In group 8, on top of the group, there is helium. Below helium, there is neon. Below neon, there is argon. Below argon, there is krypton. All of these elements except helium, because helium has a maximum of 2 electrons, because of helium has got a maximum of 2 electrons, then it can be an exception in the group. But all the other elements, all the other noble gases have got 8 valence electrons, and they are stable. They are not eager, or they're not interested in bonding with other elements or with other atoms. They are not interested in that because of having the 8 valence electrons. So chemical bonding, when it occurs, it usually occurs because these elements want to achieve the electronic configuration of the noble gases. They want to have the 8 valence electrons, which we call an octet. We usually refer to this as an octet. So they want to achieve this special octet. This is the key. If you understand this, you're going to understand your chemistry very, very well, because chemistry and chemical reactions are all about that. Just the bonding, the formation of new bonds and the breaking up of old bonds. And we're saying every element or every atom wants to have the electronic configuration of the noble gases. I want to add something. They will want to have the electronic configuration of the closest noble gas. This is also very important in understanding the types of bonding that occur. Very, very important to understand the type of bonding that occurs, or even if we talk of the formation of ions, positive and negative ions, you will understand it if you realize that the elements on the periodic table, when they are doing chemical bonding, they are trying to achieve the electronic configuration of the closest noble gas. I'm going to use sodium as an example. If sodium is element number 11 on the periodic table, so sodium is number 11, there it is. It has 11 protons and 11 electrons, and I'm just going to write how those electrons are arranged. If we call this the nucleus of the sodium atom, we have the first energy level, the second energy level, and the third energy level. The first energy level has got 2 electrons. The second energy level has got 8 electrons. And the third energy level, which is the valence shell, it has got 1 electron. This is sodium, Na. Now, behind sodium, there is a noble gas. There is a noble gas behind sodium, and this is neon. So we got neon here. Neon is in period 2, so it has 2 energy levels. Level number 1 and level number 2. It is element number 10 on the periodic table. So neon is number 10. So this is Ne. The electrons in neon, the first energy level has got 2. The second energy level has got 8. This is neon. In front of sodium, or ahead of sodium, there is another noble gas, which is element number 18. This is number 18. And the element number 18, it is argon. Ar. If I call this the nucleus of argon, it is in period 3, just like sodium. So it has 3 energy levels. So this is energy level number 1, number 2, and number 3. It has 18 electrons. It has 18 protons and 18 electrons. And this is how the electrons are arranged. In the first energy level, we got 2. Second energy level, we got 8. We got 8. The third energy level is 8 again. This is argon. Now, sodium is not stable, but neon can be found in nature without bonding to any. The neon atoms can be found in nature without bonding to any other atom. They will just be single atoms. The same applies to argon. It can be found in nature as single argon atoms without bonding to any other atom. But sodium cannot. Sodium cannot. It is not stable. In fact, it is one of the most reactive elements, sodium. But it also wants to be stable. Sodium wants to be stable. How does it achieve stability? It should copy, or it should mimic, the closest noble gas. It has 2 noble gases close to it, one before it and the other after it, ahead. If sodium tries to be like argon, if sodium tries to be like argon, it has to gain here, gain 7 electrons. It has to gain 7 electrons. If it wants to be like sodium, like argon, sodium has to gain 7 electrons. But if it wants to be like neon, neon, sodium just has to lose. So it just has to lose here 1 electron if it goes this way. So if it moves backwards, it just has to lose 1 electron. If it goes forwards, it has to gain 7 electrons. What does it do? Once again, there is the law of laziness here. There is the law of laziness, or maybe we can say the law of following the easiest path. That is also part of nature. Even human beings, they try to follow the easiest path. The easiest path. The same applies to sodium. It will not try to be like argon because it is difficult. It is more tedious to be gaining 7 electrons. Even if you're going to move to be like argon. You're moving 7 steps ahead, yet you can just move 1 step backwards and you become like neon, which is also stable. This is why sodium rather loses this electron here. It rather loses the valence electron, and if it loses the valence electron, it moves from being just a sodium atom to a sodium ion. So it will become Na plus. This is very key. This is very key. This is very important. Now, what does it tell us? It tells us that the elements to the left of the periodic table, which are almost exclusively metals, all the elements to the extreme left of the periodic table, they are metals, and they rather lose their electrons to be like the previous noble gas. So metallic elements, they form positive ions. This is the reason. This is the explanation. This is the simple explanation of that process. I now want to replace sodium here with chlorine. So I'm just going to cut out this sodium. I'm going to cut out sodium and replace it with chlorine. And you're going to see what happens. All right. Let us wrap this out. Now, chlorine is also in group in period 3. Chlorine is in period 3, just like sodium. So it has, I'm just going to, this is the nucleus. If we say this is the nucleus of chlorine, it is in period 3, so it is 3 energy levels. Please understand what I'm saying here. When I say it is in period 3, you should understand that it is 3 energy levels. This is how you can use your periodic table to understand these atoms. The period tells you the number of energy levels. But the group number tells you the number of valence electrons. It's a very important information. Now, chlorine is number 30. It is number 17 on the periodic table. It is number 17 on the periodic table. So the atomic number is 17, which means it also got 17 electrons. And this is how the electrons are arranged. 2 in the first energy level, 8 in the second energy level, and we got 7 in the valence shell, or in the third energy level. This is the chlorine atom. Let me write here chlorine, Cl. Now, just like sodium, chlorine has, before it, there is a noble gas there, neon. Ahead of it, there is another noble gas, argon. Now, if chlorine wants to be like neon, this is what it does. It has to lose 7 electrons. So for it to move backwards, it has to lose 7 electrons. Yet, if it wants to be like argon, it just has to gain 1 electron. These are the choices that chlorine has. It can move backwards and become like neon, and that process involves losing 7 of all these valence electrons that it has. It has to lose them, then it becomes like neon, which is also stable. It can achieve stability that way. Or it just has to gain 1 electron and become like argon, have the electronic configuration of argon. So what does it do? The choice is clear here. It is actually easier to gain 1 electron than to lose 7 electrons. This is the choice that chlorine is going to make. And because of this, the chlorine gains 1 electron. It now forms a negative ion, Cl-. This is why the chloride ion is always Cl minus, because there is an extra negative charge on the chlorine atom. It has gained an extra negative charge, which is an extra electron, and it forms a negative ion. But this does not apply to chlorine only. It now applies to all those elements to the extreme right of the periodic table of elements. This is what happens to the non-metallic elements, because to the extreme right of the periodic table, that's where we have non-metals. So non-metals, they form negative ions because they would rather gain electrons instead of losing electrons. We're going to see this when we're explaining chemical bonding. This is a very important aspect of chemistry, that you understand why atoms bond. I said and I repeat, atoms bond because they want to achieve stability. And the second question was, how do they achieve that stability? The answer to the question is, they try to mimic the noble gases. Then which noble gases do they mimic? They mimic the closest noble gas. So metals move backwards. They lose the electrons, the valence electrons, and form positive ions. Non-metals move forwards. They gain electrons and form negative ions. This is key. This is important. I think I should end it here. I just wanted to give you a brief explanation of chemical bonding. In fact, because this is about chemical bonding, the bonding itself, when it occurs, it is nature trying to achieve stability, and it moves in this way, and this is how it happens for metals and for non-metals. Thank you for watching the video. If you have any questions, any queries, or any comments, just write in the comment section below. I will respond to you. Otherwise, give the video a thumbs up, subscribe to the channel, and share with your friends.